Assalamu alaikum. Today we'll start talking about chapter 15, which is talking about series AC circuit. In this chapter, we'll talk about resistive and inductive and capacitive elements, introduce these elements and relation voltage and current uh, between them when I apply voltage on the resistor or inductor or capacitor. And then we'll talk about impedance and impedance diagram. After that, we'll try to solve series circuits, series examples. Uh, then we'll also try to solve series circuit with voltage divider rule. First of all rules of determining series element of the DC networks are applicable for AC network also. Okay, if you remember in series circuit, all the currents equal and the voltage summation of voltage equal the voltage source. Okay, all these current divider, voltage divider rule, all other rules, it will be applied in AC circuits. A series like this, we can make it square like this, or we can put the elements resistor, inductor, capacitor. Let us start with the resistive elements here. If you remember last chapter, when we write VR and IR, VR equal VM which is the peak, sine omega t, and IR, IM sine omega t. We see here all the voltage and current in the resistor start from the same angle, okay, zero angle. If there is shift for the voltage, for example 20 or minus 20 or 30, it will be applied here. Okay, now in this chapter we'll try to write another form, not only sinusoidal expression. Now we'll try to write this expression by phasor form. It's called phasor form. Okay, when we write sinusoidal expression, we write small letter v small, and when we write phasor form, we will write it by capital letter. Okay, this v not equal vm. Okay, this v it is RMS, and this v peak. For example, if we have for here 200 for the peak voltage, we need to find the VRMS. How to find the VRMS? By dividing root 2. 200 divided by root 2, you will get VRMS. We put zero angle since there is no shift, and similar to current, I small, this means sinusoidal expression. If we write it I capital, it will write I capital IR, this means I here which is RMS, which is Im divided by root 2. Okay, here we can say IR equal VR over R. This is Ohm's law, normal, and we have VR and IR. Let us find IR from VR. VR equal V RMS angle 0 divided by I divide by R with the angle. Okay, when we divide polar form or phasor form, we will divide the constant together, V divided by R, and the angle will be subtract. If we apply multiplication, we will add the angle. But because this here division, we will subtract 0 minus theta r. And we know that theta r, because it's a resistor, always it is 0. This means 0 minus 0, 0 minus 0 will be 0. And IR will be VRMS divided by R constant. You will find the value IR polar form or phasor form. See here, we can rewrite this form. Im will change it by V divided by R, which is VRS divided by R multiplied by root 2. This quantity, all this quantity mean I peak, I magnitude. Okay, and as we said, this ZR, which is impedance, called impedance, Now, from now toward, we will call Z anything with Z. This means impedance. ZR resistor impedance, R with angle 0. This is constant. I mean the always with the resistor angle 0 for the impedance. Let us start with the example. Example 15.1, using complex algebra, find the current IR. When he write IR small, this means he need sinusoidal expression. Okay, and then after that, sketch the waveform of IR and VR. The information given here: resistor R and voltage R, sinusoidal 100 sine omega t. What is 100 here? This means peak value, magnitude. We need to find our RMS for 100. See here, phasor form, to change from sinusoidal expression to phasor form, we need to divide by root 2. If we divide 100 by root 2, you will get 70.71 volt and the angle 0, since there is no shift here after the omega t. Okay, now we found phasor form of voltage. We need to find the phasor form of current, which is VR over ZR. V RMS with theta divided by R with angle 0. 70.71 volt with angle 0 divided by 5 ohm with angle 0. 70 divided by 5, it will be 14.14 ampere. 0 minus 0 equal 0. Now, this RMS value for the current, we need to write the final answer by sinusoidal expression. We need to multiply 14.14 by root 2, like here. If we multiply, we will get 20 sine omega t. This means the peak for the current 20, like here. If we draw the current here, the peak 20, and the voltage, the peak 100, as given in the question. And notice that we know that voltage and current in phase in the resistor elements, as we mentioned in the last chapter. Okay, all start from 0. Let us see another example. The voltage and current start from different angle, not 0. Find the voltage VR from the circuit. Now we need VR. This means the given information is IR, which is 4 sine omega t plus 30. Plus 30 mean minus 30. This means the current starts from minus 30. Okay, the current starts from minus 30 here. Let us find phasor form. We will divide 4 by root 2. We will get 2.828. Please, my student, try to use the calculator for all example. to be easier to calculate in the quiz or exam. Try to practice. Okay, now we found IR. Now we can find V, polar form. We will multiply phasor form IR multiplied by polar form of Z, which is impedance I 2.82 ampere with angle 30. You will write the angle here. Don't confuse. Only in the drawing it will be start from minus, but when we write it in the phasor form, you will write the same angle here, 30. If it is minus 30, you will write here minus 30. But here plus 30, write here plus 30. And 2 with angle 0, which is the resistor here, you will find the answer 5.656 volt and angle 30. See here, now we need to find VR since our question find sinusoidal expression VR. We will multiply RMS by root 2 and the angle will be the same since it is a resistive element. It will be in the in phase. The final answer would be 8 sine omega t plus 30. This is called waveform drawing diagram. Okay, if we ask you about sketch the waveform. Okay, and also we have another drawing called phasor diagram. Phasor diagram. We need to draw the vector. We draw the voltage VR with zero angle. This for first example, and the current with zero angle. But for the second example, which is 15.2, we will draw the voltage with angle 30, 5.565, and current with angle 30. Okay, now we'll talk about inductive elements. We know that if we fix the voltage with angle 0, VL, Vm sine omega t, phasor form will be V with angle 0 since there is shift here. There is no shift here. IL by Ohm's law equal VL divided by XL, and VL equal VRMS with angle 0 since it's given here. It is not always with the angle 0, but here since it is given uh, angle 0, we'll write it here angle 0 and divide by XL. XL here with theta L, and we know that theta here always for the inductor 90 degree. Okay, ZL equal XL with angle 90. If we divide 0 by 0 angle with 90 angle, this means 0 minus 90. It will be minus 90. The final answer with minus 90, we will write VRMS over XL multiplied by root 2. It's give you V peak and sine omega minus 90 since the final answer here minus 90. What does mean minus 90? This means the current start from 90 degree, like here. The voltage start from 0 and the current start from 90 degree. And we know that the current in the inductor, pure inductor, pure inductive circuit, current lag voltage, and here the current start in the 90 and reach the 0 after the voltage reach the 0. This means our concept and calculation is correct. The current lag the voltage, or we can say voltage lead the current. Here, example is given. Find IL. We will find here IL, and then sketch VL and IL. For this circuit. VL equal 24 sine omega t. We will divide 24 by root 2. You will get 16.968. And then divide VL divide by ZL. 16.96 divided by 3, which is 3 ohm here, with 90 angle. The final answer 5.656 with minus 90, since 0 minus 90. If we need to write this by sinusoidal expression, we will multiply 5.65 by root 2. You will get 8 sine omega t minus 90. When we need to write minus 90 here, this means theta is 90. We'll draw the current from 90 as we mentioned. This is another example, but here we need to find the VL, and it's give you IL. See here the current IL start from uh, minus 30. Since it is plus 30, this means minus 30. See here the current start from minus 30, the yellow one. How to find the voltage? We will divide 5 by root 2. You will get 3.53 with angle 30. And after that, we will multiply I by Z, Ohm's law. Okay, I equal 3.535 with angle 30, and XL equal 4 with angle 90. The final answer will be 14.14. The angle 30 plus 90. Since multiplication, we will add. This means 120. Write the final answer here by sinusoidal expression. You will multiply 14.14 by root 2 to get the peak value, sine omega t plus 120. It will be 20 sine omega t plus 120. See, plus 120, this means start from minus 120. Here also, to draw the phasor diagram. Okay, when we ask you waveform diagram, different than phasor diagram. It's called phasor diagram. For A, the voltage was 0 and the current was minus 90. Here, the current 30 and the voltage 120 degree. In both phasor diagram, you will see the current lag voltage by 90 degree, since it is a pure inductive. The current here lag voltage by 90 degree. Now we'll talk about capacitive element, similar what we did in resistive and inductive element. Here we know that from last chapter that XL is 1 over omega C, and assume VC Vm sine omega t start from 0. We will write phasor form. VC capital mean equal V RMS with angle 0, since there is no shift here. Applying Ohm's law to find IC phasor form. VC over XC, V RMS with angle 0, XC with theta C. Theta C, we know that theta C is minus 90, as mentioned here and mentioned last chapter. Okay, this means V RMS with 0 angle divided by XC with minus 90 it will be minus 90 will be 90. Okay, VRMS over XC, this is I RMS. And to find a peak value, we'll multiply by root 2 sine omega t plus 90. Since it's here 90, we will write here plus 90. See, the voltage start from the 0 and the current start from minus 90. Since it's plus 90, this means minus 90. This means the current lead the voltage by 90 degree in the capacitive element if it is a pure capacitor circuit. Okay, let us see example here. It is similar to what we did in any example before. Here we have VC 15 sine omega t. We will divide 15 by root 2. It will be 10.6 with angle 0. If we divide it by ZC, which is XC minus with angle minus 90, it will be 5.30 minus 90. It will become 90. And to convert this to peak value, multiply by root 2, and the final answer 7.5 sine omega t plus 90. Plus 90, this means start from minus 90. See here, the current starts from minus 90 and reach the 0. Then the voltage starts from 0, reach the 0. This means the current IC lead VC by 90 degree, since it is a pure capacitive element. Also here another example, but with the shift. Try to solve. Here the current start from 60, theta is 60. Okay, the voltage will start from 150. Okay, now the current is similar. It is leading the voltage by 90 degree. Try to solve this example. Phasor diagram. You need to know how to draw phasor diagram. Okay, this for example, first example, and this is the second example of the capacitor. Let us start now with the impedance diagram. Impedance diagram, impedance which is ZR, ZL, ZC. Okay, we can draw impedance diagram similar to a phasor diagram. Okay, assume this is the basic one, the R with angle 0, the inductor XL with angle 90, the capacitor with minus 90, as here, as mentioned here. Capacitor with minus 90, inductor with 90, and resistor with 0 angle. Okay, if we have this example, sketch impedance diagram for 22 ohms resistor. This means 22 with angle 0. Similar here, if we sketch for 2 kilo ohm capacitor, it will be minus 90. Okay, we'll start now with series configuration. Series configuration, we know that the Z total, which is total impedance, will be Z1 plus Z2 plus Z3. Z1 will be, it can be resistor, inductor, capacitor, and same thing for Z2, Z3. Here one example, draw the impedance diagram for the circuit in figure 15.24, which is this. Okay, we find the total impedance. Okay, the total impedance, we will add ZR with ZL. See, Z total, Z1 plus Z2, or you can write it ZR plus ZL. Z1R with angle 0, Z2XL with angle 90, R plus J XL, since XL 90, 90 we can write J. Some book write I. It is similar. I or J. This mean complex number. Rectangular form. 4 plus J 8 because resistor 4 and inductor 8. If we apply by calculator, you will find the final answer 8.94 ohm and the angle 63. And if you draw the impedance diagram here, we'll draw 4 here with 0 angle and 8 with 90 degree. To draw the resultant or the Z total, we'll draw here the resistor vector, and then end of vector number 1, which is resistor, start vector 2. We will end at this point, okay, and we'll draw from 0 to end point, and you will find here the theta is 63 and the magnitude of the impedance 8.94. Here another example. If you apply a resistor and an inductor and capacitor, now combination between three type of elements, Z1 plus Z2 plus Z3. Okay, Z total Z1 plus Z2 plus Z3 R plus JX minus JXC. Since complex real number you cannot add with the complex number, but complex number with complex number we can add XL with XC. Common J XL minus XC. This means 10 minus 12, which is this values. The final answer 6 ohm minus J2 ohm. If you apply it by calculator, you will find 6.32 ohm and angle minus 18. To draw the impedance diagram, you will see here 6 for the resistor, 10 for the inductor, 12 for the capacitor. If you draw 6 and you will go 10 for XL, and then we need to back to 12 for XC, 10 here and 2 remaining. It will be 2 in imaginary axis and 6 in real axis. Okay, 6 square plus 2 square under the root, you will get 6.32. The angle minus 18. Okay, now we need to apply voltage in the series configuration. We know that Z total equals Z1 plus Z2, and apply same rules. I equal voltage divided by Z total, which is Ohm's law. V1 equal I, since the current here equals I1 equal I total equal I2. V1 equal I multiplied by Z1. V2 equal I multiplied by Z2. If we apply Kirchhoff voltage law, voltage and the source minus V1 minus V2 equals 0. If we move minus 1 and if we move V1 and V2 to another side, it will equal voltage source equal V1 plus V2, as we know in circuit 1, Kirchhoff voltage law. And we know from last chapter, power equal voltage multiplied by current cosine theta t. Theta t is theta v minus theta I. Here some example for the circuit with the resistor and the inductor. We'll try to solve everything in this example: voltage, current, and power or factor. See here the voltage given in sinusoidal expression for 141.4 is mean peak value. If we need to convert it to RMS value, we'll divide by root 2. You will get 100 volt with angle 0. To find the impedance, we will add ZR plus ZL, which is 3 with angle 0 because resistor, 4 with angle 90 because inductor. The final answer will be 5 with angle 53. Now we have Z total and we have voltage. If we divide voltage by Z total, we will get the current. 100 divided by 5, 0 minus 53 will be 20 minus 53.13. Now we have the current, and the current go through R and XL. If we multiply the current by resistor, you will get VR. If we multiply the current by XL or ZL, you will find VL as mentioned here. I multiply by ZR, 20 minus 53.13 multiplied by 3. You will add the angle. The final answer will be minus 53. You can see here the current, the voltage minus 53 and the current minus 53. As we studied before, the current and the resistor in phase in the resistive element. I multiply by ZL, you will give you VL, 20 minus 53 angle multiply by 4 with angle 90. You will add the angle and multiply the magnitude. 4 by 20, 80, and 90 minus 53, you will get 36 point. You will notice that if we draw phasor diagram, that the current shifted from the voltage by 90 degree, and the current, since it's an inductor, will lag the voltage by 90 degree. This is the impedance diagram, and this phasor diagram. Phasor diagram, the current voltage VR is minus 53, and the voltage in the inductor 36 degree. Voltage source will be 100 with angle 0. To verify Kirchhoff voltage law, we say the summation of voltages equals 0. We will apply this. If we add VR with VL, you will get 0. Try to add them by calculator, or you convert it to rectangular form. You will find that minus J48 will cancel with plus J48, and if you add them 36 plus 64, you will get 100 volt. Now we'll try to solve the power. We can solve the power by different method. Okay, you can choose what you want, but the common method to apply voltage by current cosine theta. We have the voltage RMS. If we apply the power, you need to multiply RMS by RMS. Always your calculation by RMS. 100 by 20 with cosine 53. This is the theta angle, theta total, which is theta V minus theta I. Theta V was here 0, and the current was minus 53. This means 0 minus minus 53 will be 53. And even if you write it cosine minus 53, you will get the same answer, since cosine is even function. You will get 0.5, 0.6. 0.6 multiplied by 2000 will be 1200 watt. Okay. Another method to find the active power. We know that the real power consumed by the resistor. Because this direct, we will square the current multiplied by resistor. No need to consider inductor or capacitor. 20 square multiplied by 3, you will get the same answer. The third method, to find the power in the resistor and the power in the inductor and then add them. VR by I cosine theta, R 60 by 20 cosine 0, cosine is 0, 1. This means 60 by 20, 1200. Here, VL by I cosine theta L, if you multiply them, but you will find the theta total in the inductor 90 and cosine 90 0. This term will be cancelled. This term will be cancelled, and 1200 plus 0, it will be 1200. And the last thing, to find the power factor. Power factor, we say the active power divided by E multiplied by E. From this formula, you can find the cosine theta by divided by E multiplied by I. And power factor, if you multiply, you will get power factor is 0.6. Another form of power factor, we can derive it by this. You will end by cosine theta equal R over Z total. R in our example here was 3 and Z total was 5. This means 3 divided by 5, you will get same 0.6. By any method you find power factor or the power, it will be considered correct answer. What about lagging or leading? After power factor, you need to write always either lagging or leading. What does mean lagging or leading? You need to see the current, the total current related to voltage, total voltage. If the total current lead the total voltage, we will say power factor 0.6 leading. If the total current lag the total voltage, we will see the power factor point, 0.6 lagging. Okay, since here it is circuit resistor and inductor, we will know that the inductor will affect the circuit. This means the current will be lagging voltage. Okay, even if by drawing the voltage here is 0, and the current, if you remember, the current was minus 53. Minus 53 here is mean the current lag the voltage by 53 degree. Now the leading or lagging, not like before 90 or minus 90 or something like this. Now because it's combination circuit, it can be from 0 to 90 degree. Okay, don't forget leading or lagging after writing the power factor. Okay, here another example with the resistor and capacitor. Try to go through similar. After that they draw the waveform. Let us go through resistor, inductor, capacitor. Similar, we have resistor 3 ohm, 7 ohm, inductor 3 ohm, capacitor. This voltage with sinusoidal expression, if we need to convert it to phasor form, we will divide by root 2. You will get 50 with angle 0. Z total, Z1 plus Z2 plus Z3. 7 will be in by J positive and 3 by minus J, since it's minus 90. 7 minus 3 will be 4. 3 plus 4. Okay, and the final answer will be 5 ohm angle 53. Okay, and similar you can draw the phasor diagram. If we have Z total and we have the voltage here, phasor form, we will divide them. You will get 10 with angle minus 53. What do you think here? Is the final answer, or uh, or before you calculate the current, I mean, you can judge that from the impedance, the circuit is lagging. Why? If you remember, the inductor is 90. If you get the final Z total with positive angle, you will find the behavior similar to the inductor, which is lagging. If the Z total minus angle, you will find the behavior similar to capacitor, which is leading. And from the values, you can decide also it is lagging or leading. See here the value of the inductor bigger than the value of the capacitor. This means the behavior will be affected for this circuit by inductor. This means the current will be lag the voltage by 53 degree, as we calculate here, and we found that it is lagging, and the inductive element affect, it has more effect in this circuit, more than capacitor. Now we need to find VR, VL, VC to calculate the V total, because it's summation, since we are in the series circuit. Okay, VRI multiplied by ZR, VLI by ZL, VCI by ZC. Only substituting 10, all the current the same, only changing the value of the resistor, inductor, capacitor. Okay, you will find here the answer for VL, VR, VL, and VC. If you add them, you will get the voltage, which is 50, if you remember, 50 as given. Okay, now all these form, phasor form, if we need to convert it to sinusoidal expression, you need to multiply the RMS by peak, by root 2, RMS by root 2, RMS by root 2, you will get the peak value and sign. Here it was minus 53, here you write minus 53, and similar for the VR, and here Li was minus 53, you write minus 53. For the VL was 36, you write 36. For the VC minus 143, it will be minus 143. If you need to draw these waveform, in the exam we will not ask you all, but we'll ask you about some of them. Okay, but here we will draw all, because now in for education you will learn how to draw. The voltage was 50, or the peak 70.7 with angle 0. We found that the current, the total current, start from 53, because the theta here 53, and the VR also in 53 will start from 53. Okay, VL with minus 36, VL start from minus 36, because plus it is minus minus 36, and VC will start from plus 143 VC. Okay, it's mentioned here, every wave mentioned the name of the wave. If we need to calculate the power, it will be voltage by current, which is 50 multiplied by 10 ampere cosine theta, theta it will be 53, it will be 300 watt. Anyway, calculate the power, you will get the same answer. This is the third one. Power factor, cosine theta, cosine 53.6 lagging, or Z R over Z total, it will be zero point 0.6 lagging. Last section in this chapter, it will be about voltage divider rule. If you remember, in circuit 1, we say Vx equal Z equal Rx multiplied by total voltage divided by R total. Here, only we change Zx and Z total. Direct example we will apply. We have circuit, we have resistor, capacitor, and voltage total, and we will apply direct. If we need VC, we'll say ZC multiplied by total voltage divided by the total impedance. By calculator, you will find the answer. Direct. Or you need to find the current, like example before, and then multiply the current by ZC, you will find the same answer. By voltage divider rule, you will find the answer direct. VR equals ZR multiplied by voltage divided by total impedance, you will get 60 with angle 53. Now, using the voltage divider rule, find the unknown voltage VR, VL, VC, and V1 for the circuit in figure. We need to find all these voltage, and then we need to find V1. V1 from circuit 1, we know that after drop the voltage in first element, the remaining will be VL plus VC. Okay, apply voltage divider rule. VR, this means multiply by ZR, you will find this answer. VL multiply by ZL, VC multiply ZC. Now he apply here V1. To find V1, he considers ZL and ZC as one impedance, add them, and then multiply the total voltage by the total of this impedance, and then divide by the total impedance for all. See here, ZL, ZC, consider as one impedance, multiply by total voltage, divide by total impedance for all, ZR, ZL, ZC. You will find the answer 40 with angle minus 6.87. Last example we'll go through. Many resistor and many inductor, many capacitor in the circuit, and in the same thing it's given Henry, not and Farad, not Ohm. We need to find the total capacitance with two capacitance here, the total inductance here, and then we'll convert it to Ohm, XL and XC. We know that from circuit 1, the inductor and series circuit will add them. 0.05 plus 0.05, you will get 0.1 Henry. Okay, but for the capacitor, if you remember in circuit 1, in the series circuit, we will not add them. We will say 1 over 200 microfarad plus 1 over 200 microfarad equal 1 over C total. Okay, like parallel, which is mean 200 microfarad divided by 2. The total capacitive in this circuit will be 100 microfarad. Now we have the total Henry, total farad. We can calculate XL and XC. XL omega L, omega it's given here 377. From where we get omega? From here. multiplied by point 0.1, you will get the XL 36.7. Now XL, redraw the circuit like this. XC 1 over omega C, you will get 26 ohm. Okay, now we can solve it by any way, voltage divider rule or normal way. Okay, it is easy to find the voltage and current and power factor, and draw the phasor diagram, impedance diagram, and draw the waveform in the series circuit. This will conclude our chapter, which is about series circuit. Next chapter, which is 16, will talk about parallel circuit.